to our class, Piloting 101, Flight for Beginners. I would like to introduce our pilot, Omar, and our co-pilot, Dion.
Thank you, Kate.
Now, before we begin, are there any questions that anyone would like to ask?
Why can't we just draw a line across a map and then fly across it?
Well, just doing that would be using good old-fashioned Euclidean geometry, the form of geometry that we know and love and have been using for thousands of years. It originated back in ancient Egyptian and Babylonian maths around 2000 BC, but really took off in ancient Greek times, roughly 300 BC, with Euclid writing his big book of geometry, The Elements, which has the 5 axioms to Euclidean geometry. 1. Any 2 points can be connected to form a line. 2. Any line can be extended infinitely across in a straight line. 3. The 2 endpoints of a line, one rotating about the other, can be used to form a circle with a radius of that line segment. 4. All right angles are congruent, so they're all the same. And 5. Given any one line and a point not on that line, there is only one line you can form that will never intersect with the first line. There, however, was one problem with Euclid's 5th axiom, because him, as well as many other mathematicians past him, tried to prove the 5th axiom using the first 4 alone, which no one was able to do. There was one other problem with Euclidean geometry.
So if we can't use this Euclid or geometry stuff, what are we supposed to use instead?
Instead, we have something called spherical geometry, which is used to map the surface of a sphere, like the Earth. Spherical geometry is the study of figures on the surface of a sphere, and how planes interact and intersect with a surface. Spherical geometry has existed for a long time, since around 100 AD. When Ptolemy dabbled in the area. However, it was completely useless information, no applications, until first became common knowledge that the Earth was in fact round. A contribution to spherical geometry came in the 1700s through the work of Leonhard Euler, writing multiple memoirs on topics such as spherical trigonometry, areas of triangles, on spheres, cartography, and mapping spheres to flat planes, curves on spheres and spheroids, and much more.
Yeah, but how does that actually help?
Spherical geometry is the method in which we pilots, as well as ship captains, use in order to navigate the globe. When a plane intersects with a sphere passing through the centre of the sphere, the corresponding circle that is formed by the cross-section of the sphere that is the same diameter as the sphere intersects with is known as a great circle. The most commonly known example of a great circle is Earth's equator. Due to the properties of a sphere, the shortest path between 2 points on a sphere lies along the diameter of a great circle of that sphere. This is the application of spherical geometry that we use today in order to find the shortest, most efficient route to travel between 2 destinations, like 2 cities. A spherical triangle is formed by the intersection of 3 great circles. Using points like the North and South Pole as reference, we're able to determine the shortest distance between 2 cities on the Earth using the cosine law for circles on the plane, where A refers to the unknown third side, B and C refer to the 2 given sides, which can be calculated using the poles as references, and where capital A refers to their included angle.
When this method is used for navigation, we get a much nicer result.
Now let's begin the seminar.